Hi distinguished students, once again you are welcome to our lesson series in Math 106. Today's lesson topic shall be Poisson distribution. I hope you enjoy this topic as we go along. You are welcome. As it is well known to you, my name is Dr. Adirugba Njorin from the Department of Mathematics, Faculty of Science, Lagos State University. Objective of the lesson. At the end of the lesson, we should be able to 1. Identify what the Poisson function is, 2. Generate probabilities using Poisson function, and thirdly, obtain mean, variance, and standard deviation of a given population. This distribution is another way of generating probabilities of a given sample space. In general, Poisson probabilities function is applicable to events which are usually for a fixed interval of time, length, area, or volume, as the case may be. From the binomial distribution defined in previous lesson with mean NP and variance NPP, when n becomes very large and p is very small, the calculation of the various probabilities becomes very tedious. When this becomes the case, we apply a probability distribution function which approximates the binomial distribution. This new probability distribution function is defined in expression 2.01, where mu is equals to np is the mean number of successes. It can be shown mathematically that the variance is also equal to mu. The only condition required for this probability function to hold is n is large, p is so small that the product np remains fixed. The probability function is known as Poisson probability function. There are many real life situations when this probability function is applicable. Some of these are: 1. You might observe the arrival of cars at the gate of a car park between the hours of 8 a.m. and 9 a.m. on a given day. The arrival of a car at the park is discrete event because its arrival time is single point on the continuous 1 hour period. B. During the past 30 minutes, the public light system has been switched off 4 times. It is not possible for us to say exactly how many times it will be switched off, because the switching off is an isolated event which occurs over a continuous time space. The number of accidents occurring in the factory over a period of 1 year. 4. The number of faults in a length of cable. 5. The number of errors in a page of a printed book. In general, a Poisson probability function is very useful for rare events of this kind discussed above, which are usually for fixed interval of time, length, area, or volume, as the case may be. The understanding of this distribution is better aided with worked example. An electronic company manufactures a specific components for a tuner amplifier. It is found out that out of every 1,000 components produced, 8 are defective. If the components are packed in boxes of 250, find 1. The probability of obtaining 0, 1, 2, 3 defective in a box. 2. The probability that the box contains at least 3 defectives. In this case, probability of a defective is 8 over 1,000, which is 0.008. Sample size is 250, NP is 250 times 0, which is 2. That is the mu. You could use binomial probability, but because p is small, you now apply Poisson distribution to find the required probability. Using the Poisson distribution defined here, we have for p of 0 to be 0.135, p of 1 to be 0.2706, p of 2 to be 0.2706, p of 3 is to be, we will find it to be 0.1804. Now, probability of at least 3 is 1 minus probability of 0, probability of 1 minus probability of 2, and you computing all other probabilities and minusing them, adding them and minusing them from 1, you have probability of at least 3 to be 0.3235. You have the following activities for to solve and determining, to get better understanding of the course of the lesson. You have the following activities. Summary. Poisson distribution is another way of determining probabilities of some sample trials in a given sample space. This has been demonstrated here with several examples. You should have to yourself the Poisson distribution statistic table for calculating the values of the probabilities. You should be able to recognize the Poisson distribution it uses in calculating probabilities. Means and variance should be well known to you now. My distinguished students, for references, please refer to references provided in previous lessons. Thank you. My distinguished students, I hope you really enjoy this lesson. The activities given to you should be done and references should be consulted for better understanding of the course. Thank you. Goodbye.